Ah, okay, that's better. Alrighty, that took a while, but okay. Were there any homework questions from pages 13 and 14 that I can take up? Yep, 12. Was there anything else? Yep, 13. Yep, 5. Sure. Anything else? Okay. So number 5. The manager of a baseball team, here I'll put it here because I think it will help people on the internet. Okay, so 5. The manager of a baseball team has picked 9 players for the starting lineup. In how many ways can he set the batting order so the pitcher bats last? So I'm assuming there's only one pitcher. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the pitcher is here. So how many people do we have left over to do this? 8. So it's 8, 7, 6, 5, 4, 3, 2, 1, or 8 factorial. And that should be the answer. Could anyone plug that in their calculator and just compare it to the answers? And just let me know if that's okay. Does it match up with the answer at the back? 4320, and the answer to 5 is 4320. Okay, what's the next one? Number 12. So here's number 12. Which one in 12? Either one? Okay, why don't I do B? 12B. Do you mind hitting the door? Closing the door. Thank you. So we have 3P n comma 4 equals P n minus 1 comma 5. Okay, so the formula for P n comma r is n factorial over n minus r factorial. Is that okay? So we're going to plug that into the formula and solve. So we have 3 times n factorial over n minus 4 factorial is equal to n minus 1 factorial all over n minus 1 minus 5 factorial. So 3 times n factorial over n minus 4 factorial equals n minus 1 factorial over n minus 6 factorial. So what we do is the first thing we have to do is get rid of the factorial. So we'll work with both sides and see what we end up with. So we have 3 times n. We'll bring the numerator down to the denominator. N minus 1, n minus 2, n minus 3, n minus 4 factorial all over n minus 4 factorial. And that equals n minus 1, n minus 2. We'll bring it down to the denominator on this side. N minus 3, n minus 4, n minus 5, n minus 6 factorial over n minus 6 factorial. So let's divide out. We can divide that out. So I'm going to divide out no n over there. There's no n over there. By n minus 1, divide it out. I'm going to divide out by n minus 2. Divide both sides of the equation by n minus 2. Divide both sides of the equation by n minus 3. Right, I did that. So now we're left with 3n equals n minus 4 times n minus 5. So basically this is a nice quadratic to solve for. So n squared minus 9n plus 20. So I'm going to subtract 3n from both sides, and I get n squared minus 12n plus 20. So we could go 2 times 10, right? 0 equals n minus 2 times n minus 12. So n equals 2 or n equals 12. But yeah, my bad. Thank you so much. So n equals 2 or n equals 10. Thank you for catching that. So, but let's check. Does our original question was, can we arrange, let's check n equals 2, okay? Can we arrange 4 things if there's only 2 things to work with? No. So this is inadmissible, right? So therefore, n equals 10. Can I explain anything better? Is that okay? Whoever asked, yes. Okay, because do you see if we have for arrangement of 2 things? That, yeah, we can't, oh sorry. Part of the equation is if we put n as 2, so it's going to be 4 arrangement of 2 things. Can we arrange 4 things if there's only 2 things to work with? Yeah, so n cannot be 2. N must be 10. And you can see, you can arrange 4 things if you have 10 things. You can arrange 5 things if you have 9 things, right? Because 10 minus 1 is 9. Okay. It has to be larger than or equal to r in order for it to work. So the next question was number 13. For natural numbers n and r, with n is greater than r, prove that an arrangement of n things. So which one in 13 would you like me to do? Sorry? B? Okay, let's do B. B is probably the hardest one, so if you understand 13b, you can probably do 13a. But if not, we can do it, okay? So P n r plus 1, we want to prove that this is true. Remember always, when you're proving, that you separate the left side from the right side. So left side equals P n comma r plus 1 all over, oh sorry, for some reason I did that, and that equals n factorial over n minus r plus 1 factorial, and that just equals n factorial over n minus r minus 1 factorial. Right side is equal to n factorial. Oh, I see. Oh, that's just n minus r, my bad. N minus r times n minus r times n factorial over n minus r factorial. Okay, so there's nothing we can do here. We're stuck here. So let's see what we can do on the right side. So you have n minus r times n factorial over n minus r. I'm just going to break it down to, I'm going to go down 1 factorial. Then you can, yeah, you can divide it out, and that will equal n factorial over n minus r minus 1 factorial. So left side equals right side. May I explain anything better? You're okay with A? Why don't you give A a try on your own, and if things don't work out, we can do that later. So let's do today's lesson which is on what happens when some object, you're arranging things and some objects are alike. Okay, look at what happened. This is an example of arranging three things and all things are different. Well, you know there are 3 factorial ways to arrange 3 things which equals 6. So these are listed here, A, B, C, A, C, B, B, etc., etc. Okay, here's a list of 6 arrangements of A, B, C. Now, what happens here? Well, let's take a look. So notice A1, A2B, A1B, right? Here's an arrangement of all of them. But can you see that this one is identical? They're the same, right? But you see, we want permutations. We want them to be different. Can you see that 2 and 4 are the same and that these two are the same? These two are in effect the same. So the idea when you have objects that are alike, so that you're not going to put subscript 1 and subscript 2 on the A's, right? We don't do that. So when two things are alike, we have to divide by those things that are the same. Are the same or identical. So really, do you notice there's only 3 things that are the same? Forget I said that. Notice you have 3 different arrangements when 2 objects are the same. So what we do is we're arranging 3 things and we divide by the order of those things that are identical. And this will equal 3 times 2 times 1 over 2 times 1, and that equals 3. Okay? You'll have to, I don't know what you mean when when 2 arrangements are the same, we don't count them. Yeah, right? So AAB is identical to AAB. We only want to count that once because we want different. Sorry? Okay, there's 3. We're arranging 3 things AAB, and then we're dividing by 2 things that are identical. Okay? So, this is the general overall formula. The number of permutations of n objects, of which A objects are alike, another B objects are alike, another C objects are alike, and so on, is, well, if you're arranging n things, and you divide by what's alike. Okay? So let's just do some examples. 7 sheets of paper are on Shannon's desk. If there are 4 sheets of blue paper and 1 each of red, yellow, and green paper, how many ways can she stack the paper when she tidies her desk? So there's 4 sheets of blue, so 4 identical, and then 1 of each. So the total number of sheets is what? 4? Sorry, 7. I was thinking of what's identical. And then identical are 4, right? So how do you think we would work that out? Well, perfect. And that equals 210 different arrangements. No. We'll worry about combinations later. Okay? Yeah. Combinations is a little different. Okay. So these are different, right? They'll look different. Are we good? Consider the word logo. Determine that, well, I don't, let's just look at this. Determine the number by writing it out. We won't do a tree diagram or we'll go crazy. So let's just, and then using factorial. So factorial is the easiest, right? Because you have four different things, well, not different, you have four things you're arranging, right? Two of them are identical, and that equals 12. So using factorials is easy smeezy, okay? Because 4 factorial is 24, divided by 2 factorial is 12. Now if we were to write them out explicitly, that's a little bit harder. And here. So the first one will be logo, right? Now we could swap the last two, so you're going to get lug. Now we could put the G in that spot. Lagu. I won't try to pronounce them because it sounds ridiculous. Or you could have O-L. You guys can take my word for it. I'll just give you a nice list here. You could have Golo. That one's easy to say. Golo. Yeah. And 6 you have Gloo. Yeah. You could have Ghoul. Ghoul. You could have Ogol. Ogol. And then you have 9, which is O-L. But you can see how... oh, yeah. It's O-L-L. Uh-oh. Oh. Oh, thank you so much. I don't know if I could have figured it out as quickly as you. The first one, is that right? Number, yeah. The first L is a G, and number 10 is O-O-L-G. Anyone want to care to find the last two? Oh, you guys are good. O, O, O-log. So let's see, there's 3 that start with L. There's 1, 2, 3 that start with G. How many? But there's 1, 2, 3, 4, 5, 6 that start with O. Sounds like a pattern.
Starting with O, you have, so basically you have O and the permutation 3 factorial, so you have 6.
Oh.
Starting with L or G, you have double O's. So
Okay.
you have 3 factorial.
Oh, interest. Oh, clever.
So
Okay.
you kind of can combine methods 1 and 3 using explicit reasoning as well as factorial.
Yeah. Okay, number 4. Uh-oh. Okay, so we have 2 S's, right? Let's just list 2 U's, 1 B. We have 3 T's, 1 I, and 1 E. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. Of which we have 2 S's, 2 U's, 1 B, 3 T's, 1 E. what is this? Yeah, and an I, right? One I, one B. Okay, but they want to begin with I and end with B. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a begin with I, end in B, one choice for each of those. So our B is gone and our I is gone. So now we're left with 1, 2, 3, 4, 5, 6, 7, 8 letters. So we have 8, 7, 6, 5, 4, 3, 2, 1. But some of those are the same. So our final answer becomes, those are gone. We won't worry about it. 8 factorial over per perfect. Perfect. You're right on. That's 1680. Huh? I'll put it up as soon as I'm done. How many permutations of the letters Mississauga do not start with an S? All right. Let's do it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. We have it 1 M, 2 I's, 4 S's, 2 A's, 1 U, 1 G. Thank you. Thank you for helping this old lady. Yeah, it's most appreciative. Okay, so let's do it. Okay, we have 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But no S. So how many letters do we have to choose from? 7. Perfect. Now we have 10 letters to play with, because we're down 1. 10, 9, all the way down to 3, 2, 1. So now we have 7 times 10 factorial, and just divide by what's the same. 2 factorial, 4 factorial, 2 factorial. And when you work that out with your calculator, you should get 264,600. I've always found this math to be the most interesting, because it's a little bit of thinking. Was that something I was supposed to hear? Or? No, everybody's good? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. 1 I, 3 S's, an O, a C, and an L. Am I right? We have 1 I, 3 S's, 1 O, 1 C. Oh, 2 E's. Did I forget the E's? Okay, thank you. All right. How many permutations can be formed using the letters isosceles? And C has to be in the middle. Okay, we've got 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. So C has to be in the middle. There's our C. No choice there. There's just one choice, which is no choice. Okay. All right. And so then we have 8 letters left. So basically it's 8 factorial and divide by what's the same, right? Yeah. That's equal to 3360. Oh my. Begin with O but do not end in L. Fine. What? So O is, there's only one O, there's only one L. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So no O. No O.
No, begins with O.
Oh, okay, okay, thank you. Okay, and this one is no L. No L. So you do your restrictions first. That's the big lesson here. Do restrictions first. Always, 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 always. So no L. So if there's no L, we're down to, that means there's 7 choices for that one. So now we're down 2 letters, and that makes 7 left, right? So it's 7 factorial over, what's the same? 3 factorial, 2 factorial. Oh, yes, you're right. It's 7 times 7 for that one. And yeah. Thank you. Thank you. So this is going to be 2940. Good? The permutations have e's in adjacent positions. So these are together. So how many ways can you arrange these guys? Oh, 2 factorial divided by 2 factorial. There's only one way, right? So we'll just treat this as one character because they're together, and we can't arranging them that they're the same, so we don't do that. So there's 7 letters left. Okay, so how many things are we arranging? 8 things, right? 8 things that we're arranging. Now tell me what we divide by. So shall we leave it at that? That's 6720. 6720. Yep. On the bottom, because if you want to divide by 2 factorial, you're going to have to multiply this by factorial. Right? So the thing is, because we're not arranging, we've canceled out the 2 e's and we have a new character called EE. So there's nothing that's the same with EE, right? Are there any questions? Anything else I can explain better?